Thanks so much, Heather, and thank you to the Grain Extension Program for having us here. We're really happy to talk to you about what we do at the bakery, Elmore Mountain Bread and New American Stone Mills. This is Blair. She's the other half of our team. She's involved a lot more with the baking nowadays than I am. Basically does all of the baking, mixing, shaping, and delivering, and I just kind of fill in the gaps and help out as needed. But most of my work is spent building stone mills. So this presentation is called The Anatomy of Wheat, and this is the stone milling aspect. But throughout history, the cultivation has built communities, but I guess you could also say that communities have come together to cultivate wheat. So I'd like to talk for the first part of our presentation about my connection with wheat and the community that has grown around this grain here in Vermont. So the way the bakery started out was Blair and I were both chefs working in restaurants in Vermont. And Blair was running a little cafe called the Bee's Knees, and there was a guy who would bake bread a couple days a week and sell it to her. And he came in one day and he said, "Hey, does anybody want to buy a bakery and a house and 10 acres of land?" And we were kind of interested in doing something different from what we've been doing in restaurants for a while. And so we said, "Yeah, we'll come check it out." So we bought this little bakery called Elmore Mountain Bread. And in the beginning, this small village bakery, we were baking off of a Allen Scott oven. There's a picture of Blair in the very early days. And because we just sort of dove into this, not being bakers at all, we had a few weeks to learn from the previous owner how to bake, how to mix, how to fire the wood-fired oven, how to do QuickBooks and the whole lot. And we quickly grew and started to learn how to bake better and better. But in order to do that, we had to sort of reach out to other wood-fired bakers. Some would come to visit us, others we'd go and visit them. And we found that there was a real kind of community of bakers that we were excited to join and be a part of.
And this is all pre-social media and Instagram. And so, that sort of connectivity that exists now to create so much dialogue and excitement around these things didn't exist then. So we would just visit and get our hands, in the dough with other bakers and share ideas. So
that was some through the Bread Bakers Guild of America. We were on the chat with that a lot to connect with a lot of these other bakers. But so as we grew with this oven and learned how to bake bread out of it, we found that there are a lot of things that could be improved on. And one day we were baking and we heard a big thunk and a big chunk of the hearth fell out, and we decided, we better do something about this. And I had a lot of ideas on how I wanted to improve on that oven, talking to other bakers. And so we decided to move forward and ended up meeting a friend named William Davenport, who was a masonry heater builder and had built a couple ovens, but nothing quite like this. And so we collaborated and worked on the design and built this first Turtle Rock oven. The difference with this oven is that it has 3 doors wide instead of the single door. We use a mechanical loader to bake out of it, or to load and unload. And it was quite a bit bigger than our original oven. And once we figured it out, the bread was turning out pretty nice. So that kind of community of bakers that we had gotten to know started to come back around and say, "Hey, this oven's pretty great. Do you think we could get one of these for ourselves?" So William ended up going about and building another probably 20 ovens all around the US for other bakeries who wanted to bake the same kind of bread.
The nice thing about this was that it kind of was our introduction to thinking about, the equipment that we have in our bakery and how we were able to think about how it fits into our system and what our end goal for the bread is. And if we have this picture of what we wanted our product to be, that we could think dynamically about these pieces of equipment, and this that we wanted to be able to use to get a certain aesthetic for the bread, style of bread, characteristics. And so it kind of like laid the foundation for us to be able to think about our equipment and realize that if there wasn't necessarily something out there that was exactly what we were looking for, that we could, communicate, share ideas, and think outside the box and design things that worked for what we were looking for our end product to be.
Yep. And so this is the bread we were baking, and it was working well. We had sort of gotten our feet under us with the baking, and we're making nice bread. But I got to a point where I was looking for a new challenge. I reached out to a friend who's down in North Carolina named Dave Bauer, and he had the second version of our oven built. And the one thing that he was doing different was he had an Osterroller Austrian stone mill, and he was working with farmers in North Carolina to use the regional grain. And I called him up one day and I said, hey, I'm kind of curious what you're doing. I'd like to get into milling. Can you tell me what kind of mill I should buy and what size? And he said, oh, well, hold on, let me do something for you first before you get into this. So he milled up a whole bunch of different grains that he had, and he overnighted us a box of fresh flours. And this showed up on our doorstep, and we opened it up, and we're just blown away. We had been baking almost 10 years at that point with organic white flour that was coming from Quebec. It performed great, but to have these flavors and textures and aromas and grain was something I had never experienced before. And we knew that once we smelled that and started to test and play around with it a little bit, that we wanted to be able to create that same kind of bread in our bakery using those flours. So, and we figured, we're already baking bread in a naturally leavened manner out of a wood-fired oven, all shaping it by hand. So we figured, why not try to mill all of our own flour as well? So I sourced some millstones. This is a paint granite millstone from Meadows Mills. They cut our first set of stones for us. And then I went about researching in old books and looking at other designs, how mills were built throughout time, as well as how they cut the stones, the mechanics of it, and worked with a friend who was a welder and another friend who was an engineer, and we built our first mill system.
One of the things about our goal with this too, in conversations with a few bakers at the time who were milling, and both of them, actually, this was Dave Bauer and Josie Baker out in San Francisco. He was just opening the mill at the time, and they were using just portions of stone ground flour and combining it with the roller mill flour that they were sourcing from other places. And one of the things that kind of led us to thinking about designing our own mill, as opposed to purchasing one from overseas or somewhere else, was that all the bakers we knew of at the time were just only able to incorporate a portion. And so we were like, if we're going to do this, we want to be able to use all stone ground flour and be able to it's like, if we're going to purchase grain with the ultimate end goal of purchasing grain from Vermont farmers and working with Vermont farmers, which is another piece of information these other bakers were excited about, and also got us jazzed about the whole idea of using stone ground flour, was not just like the characteristics of the flour and the aroma and the baking qualities and all of these things, but it was taking our relationship with our product and our community and bringing it to another level of connectivity and connection there. And so what we really wanted to do was, we knew right away that we didn't want to use just 20% or 40%, whole grain stone ground flour. We wanted to be able to use 100% and figure out how to be able to do that. And at the time, we weren't able to find no one was using a stone mill that was allowing them to do that. And so that kind of set us on the trajectory of being like, okay, well, maybe we should try and design something instead that would allow us to do it.
Mhm. And another part of that is that at the time, this is 2014, I guess,
Yeah.
when we were doing this, there wasn't a regional mill. So, other regional mills have come about since then, Farmer Ground Flour and AnyK Grains. But we were figuring this out as we went. And so we became, a baker miller in this case. And as you can see in our system here, we have the mill, and then we purchased the sifter in the foreground there from Meadows. And the way we chose to make our flour, and we'll get into this a little bit more later, was that we had been making breads the way we had for the last 10 years. And so when we started milling, we didn't want to completely create a whole new line of breads and really, really shock our customers. So we began to mill it and gradually add in stone ground flour. And then, we went from 20 to 40 to 60 to 80%. And then one day I just said, heck, I gotta give it a shot. So at the time I was mixing, and Blair and I shaped, and then she would bake. And I mixed our country bread with all fresh stone ground flour. And Blair kind of looked at me funny, like there's something different going on here. But we just jumped in and did it. The bread turned out great. And then we just kind of switched all of our breads over to using fresh milled sifted flour.
Yeah, I was very interested in taking the boiled frog approach with incorporating the flours, and I suppose just different personality types. But it was literally being on the bench that one day, I was like, something is very, very different here. And he hadn't told me about it, and it was just like, I may or may not have just gone 100%. And it was really interesting because the aesthetic of the bread, it was hands down like the best loaf of bread that we had ever made up to that point. And it was terrifying because it could have gone the opposite way, I suppose. But the flavor was unreal. And as soon as we hit that point after the end of that bake, we knew that there was no going back.
And as we did this, we didn't necessarily broadcast it to our customers what was going on. We just sort of figured we'll just sort of slip it in and see what happens. But Blair, when she was delivering at the grocery store, many times customers would come up and they say, "Man, your bread is, it's different, but it's just better." And I can't quite put my finger on it. It tastes different.
Their favorite thing to say was, "It tastes more like wheat." And I was like, yes, that's the idea. There's far more flavor coming through it. So.
Yeah, and so once we had kind of figured out we knew what we were doing, we changed the label on our breads on the back of the bags so that we could kind of communicate this message of what we're doing and why we do it. And so you can read there. These are some of the topics we'll be talking about later, but why do we stone mill our flour daily? For flavor, we want to make the best bread possible, and fresh mill flour has incomparable flavors. For nutrition, all the parts of the grain are retained inside the flour, and with tradition. So we were doing wood-fired baking and long fermenting with naturally leaven, and wanted to revive this tradition of stone milling. So we had figured out how to bake, we had figured out how to mill, but our other goal of all of this was to bake with local grain. So what we had been doing is reaching out, and you guys knew this guy, Jack Laser was one of the pioneers of grain growing up here in Vermont, and said, "Hey, we're starting to mill our flour. Do you have anything available?" And it was not a good year for wheat at that time, and he didn't have anything for us. So we ended up sourcing some of that grain in the beginning from larger mills. We got stuff from Heartland Mills and Champlain Valley Mills. Even Milanese up in Quebec was able to ship us grain. And really that was a good way to start for us to learn how to mill our own flour, because that grain was clean and it was specced, so we knew we were getting something that was 12 to 13% protein and around a 400 falling number. So we didn't have to worry about some of the challenges that come with sourcing the grain locally, and kind of just figured out the milling aspect of it. But a friend of ours was at the Montpelier Farmers Market, and he said, "Hey, I know these folks next to us, the Rogers. They're selling raw milk, and they planted a bunch of grain. You should talk to them." So we put Blair on that, and she called them up and said, "Hey, we've got this bakery and a mill, but we don't have any Vermont grain." And they said, "Well, that's funny. We've got all this grain we're growing, but we don't know exactly what we're going to do with it." So after they harvested the grain, they got it tested at the extension center there, and it tested fine for us. And they brought some samples up, and we sat down and milled up some flour and made some bread, and it worked great. The variety that they grew there was Redeemer, which, as Heather was showing yesterday, was one of the varieties that has had a lot of success growing in Vermont. And it's a modern variety, but it's been really reliable. And it's kind of important to note that when you're working with these small farms, we were excited to know about things like Turkey Red or Turkey or Red Fife, but what we found was important was to have the farmers grow what worked for them. And these guys just picked this grain, and it was successful for them. And then the next year was successful, and they've been able to grow since then, to the point where the next year they had enough wheat that they actually allowed us to drive the combine with them, which was quite a treat for a baker to see this whole side of the world of wheat farming. Since we got that Redeemer wheat, we really wanted to feature it. We still were buying some of the grain from the bigger mills, but we didn't want to blend it in this case. We wanted to really focus on, this is the first wheat we had gotten from Vermont, and so we created a bread that was unique and made with 100% Vermont grown wheat, and we call it our Redeemer bread. And found that happened to be a serendipitous name because we felt like we were using Redeemer wheat, but we were also redeeming a tradition of grain that was grown, milled, and baked for our community. After that, we connected with more farmers. This is Seth Johnson, who has Morningstar Farm up in Glover, and he's grown, he had grown some grain called AC Berry at that first time we met him, and the kernel size was really small, and some other people were having trouble using it because their yield was like 50% flour, 50% bran. So we agreed to figure out how to use it and make the most of it, and we ended up blending that into some of the other grains just so that we could utilize it. And then the year after that, he grew Bowls, which is the wheat that you have in your sample boxes that were sent there, and had several successful years with Bowls, but also this last year now he's grown Expedition, which was a winter wheat. And that Expedition, we were a little bit skeptical of in the beginning because it would test it at, I think, 9% protein, but Blair's been doing some test bakes with it. And when normally we would have shied away from it, we've actually had some really good success with the breads that she's been working on.
Yeah, and that speaks to a lot of the information that was presented yesterday, and just thinking creatively about working with the grains that are made available to us. I wasn't having a lot of success with it in hearth breads, and so I just had to shift my thinking about what I was going to do with it for this season, and am choosing to do 100% whole grain pan breads instead that are turning out extraordinary. And it's really stimulating as a baker, and to and challenging for me to be presented with, having X amount of grain to use in a year and committed to that, and using the tools that I have as in the bakery to adapt my roster of breads for the season based on what the grains that these guys have grown. And it's beautiful.
Another farmer in Vermont, these guys are growing a lot of organic wheat. This is Nitty Gritty Grain Farm. Tom Kenyon and his son David's moved back to the farm to take over a lot of the farm operations. They've been growing mostly Redeemer wheat as well. I think they have over 100 acres that they planted last year with a successful crop. And that they represent about half of our supply of grain that we buy in Vermont. Also, Thornhill Rye is another farm that we're working with. Todd Hardy from the Northern Grain Growers Association has been growing this rye to make whiskey, but also happens to make really nice bread. And in the beginning, when he didn't have a way to grind that rye for making the whiskey, he would come with a whole pickup truck full of 2,000 pounds of rye and spend half the day milling it on our mill. And we were happy to get him started with that and watch him grow. And we also created a bread using that rye to feature it. And then the last farmer here that we've been working with more recently is Sean Jang. They've started a business called AnyK Grains. And he's working on land that has been in his family for a while, and they had a dairy farm, and they've transitioned away from doing dairy, but they're doing heifer rearing on the farm. And it seems as Sean's family is taking over more of the farm operations, he's been looking to grow more grain. So here he's standing with some of that. He's grown barley for malting, and then has also had a few successful harvests of wheat. We've been getting his warthog grain from him and milling it for them, and then trading it back so that they could sell the flour and get the value added sale of selling sifted as well as whole wheat flour to some of the other bakers and customers. And they've continued to grow. Here's right in the middle of getting close to harvest time, standing in the field of wheat, looking around at their land. So where this has brought our bakery. So we've accomplished our goal, which was to source all of our grain from Vermont. And, we're not huge. We buy around 50 to 60 tons of grain in Vermont. But, what we feel like we're kind of doing is creating a model of how this can work to support a regional grain economy. And, there are many reasons for that, but it's keeping those dollars in Vermont, as well as food that's grown in Vermont is feeding Vermonters, and it's creating a lot of resiliency in our food system. When the pandemic hit, we hadn't milled much flour for retail sale. We had mostly just been milling it to trade with our farmers or to use for our own bread. But there was no flour on the shelves there for a while. And so we started to mill it and bag it up in 3 or 5 pound bags. And anybody who came by, we would we'd be happy to sell them a bag of flour so they could continue baking. So that's a sort of Elmer Mountain Bread's bakery story of what we've done. But what ended up happening is that this community of bakers that we had talked about in the beginning there, well, they started to come around again and ask questions, say, hey, what are you doing with your mill? Would you ever be interested in building a mill for us? And so this is Jonathan Bethany. He's an old friend he has Selu Bakery in Washington, DC. He also ran the bread baking program at the Bread Lab out in Washington State. And so he was one of the very early mills that I started to build for people. And what we wanted to be able to do is figure out, how we could get this beautiful fresh flour to to be accessible for more bakers and farmers and millers. So our friends, the Rogers, happen to be good friends with the head of the local granite union here in Vermont. And he said, you know, Vermont has this really nice quality gray granite from Barry. I bet we could find somebody to cut it for you. So I reached out to one of the sheds, and they said they had the facilities to be able to cut the stones and cut them into discs like that and plane them flat, put the hole in it. So we started to buy stones. I read through old books and continued to explore the aspects of stone cutting, and learned how to cut the grooves in the stones like that. And then started to build those first mills. These are the first couple. And you can see I was doing that in the other half of my garage in the middle of winter. And in the beginning, I was, creating a very utilitarian mill that I thought was going to be, do a nice job of milling flour for the bakers. But over time, I found that the bakers wanted them to look a little bit nicer and have stainless steel, and so we created a bit more attractive design that was functional, and it was really so that the bakers who choose to do this and mill their own flour, that they can show the mill off, because it's really a symbol of the extra effort it takes to source local grain, mill it fresh, and then figure out how to bake with it. And so New American Stone Mills was born, and instead of just building a couple mills for friends, now we've built over 150 mills and shipped them all over the world. There's, I think, 7 mills just in Vermont, with some farmers and several other bakeries that are looking to mill and milling all of their grain fresh. And this was kind of what our goal became, to build this community of bakers. We've been part of it as bakers, but now we're helping to continue that mission to have more farmers and bakers to fresh stone mill all of their product. So hopefully that's gotten you a little bit excited about our story around wheat. So what we'll do now is talk a little bit more about how to do it yourself. So stone mill is really one of the choices that you have if you're looking to source grain and mill it. It's the connection between the farmer and the baker. Without this tool, you're not going to be able to make flour to make bread. The other advantage of having your own stone mill is that you can source wheat that may not be acceptable in a commodity system. So it could be more interesting varieties, like things that are being tested. It could be stuff that maybe has a little bit too low a protein and wouldn't be acceptable to be sold to a big industrial mill. You can still make the most use out of it and create something interesting. And this size mill also is an appropriate scale. So it's a pretty significant investment to set up a large regional mill. But with a smaller mill like this, you can work to source your grain locally for your community.
We found too that there's a lot of bakers where in places where there are regional mills, stone mills, or supporting other flour mills that are present, which is really important. But it's also been a tool we found a lot of our baking community to use, if there is somebody happening to grow some really interesting heirloom corns or varieties of rye on a small scale, and they don't have an outlet to be able to, as part of their rotation, to be able to put these grains, to sell these grains into a larger market. It's been really interesting to hear the stories of bakers who will buy, the majority of their flour from King Arthur or from AnyK Grains, but to have a mill of some sort in their business in their bakery to be able to utilize these small scale local grains, to be able to use it as inspiration and something exciting to get the bakers or their staff excited about, you know, experimenting and changing things up and building flavor profiles and all of these other aspects.
Mm-hmm. And so the approach that you have to take when you're stone milling yourself is quite a bit different. So what are you trying to achieve? So with a large commercial industrial mill, they're trying to efficiently mill the most flour they can by blending a variety of wheats to hit a spec and produce the same consistent flour all the time. So no matter who they ship it to, they know what they're getting. But when you're a local baker miller, you have to operate the mill in a really different way. We get the Redeemer wheat from Nitty Gritty Grain, and we have that same grain for a whole year. And so what you have to do is use that mill to mill it and figure out how it performs by baking with it. And then you kind of have to adapt your recipes and your techniques. Sometimes it's your product to work with the grain that you can get, as opposed to trying to make the flour fit the bread. There's a real difference in working with the annual harvest and the varieties that you can get.
That's a really, and to interrupt again, that's a really interesting way to create excitement and dialogue also within your community and with your customers, because it opens a door to be able to say, okay, this year our lineup of bread is going to be a little bit different, and this is why. And to be able to tell that story and bring that awareness around, you know, say, okay, things are changing, and to be able to have that, use it as a voice or a conduit for conversation and education about local grains and varieties of grains, and to explain to them why, whether it's information on your bread racks or if you have a retail bakery, to be able to put that out there. It's a way to create a conversation that we felt didn't really exist before with our community,
and educate the customers too that things change. Like towards the end of last year, when Todd was running out of his supply of rye, we had to bring in some other rye, and we said, yeah, this is still a rye bread, but it's definitely not the Thornhill Rye bread that we've been making all along. When his next harvest comes in, we'll bring that back, and it may be a little bit different, but we'll make it as good as we can.
And to remind people that this isn't just something that is always the same. It's an agricultural product that is being produced here locally, and to remind them about what this staple food is. It seems like people have forgotten. So,
so how to operate the mill? So stone milling it's all about inclusion. You put the whole grain in, and you get the whole wheat comes out. There's no separation at the point of milling. With roller milling, the idea is that you're peeling the grain apart layer by layer to just give you the starch. You know, Randy talked about that yesterday. The nice thing is that all of that germ and bran is milled in there with all the nutrition. When you're running the mill, there's an old expression of keeping your nose to the grindstone in regards of paying close attention and working hard. Well, all those same senses are used to operate any kind of stone mill. You have to use your eyes, your ears, your fingers, and pay attention to what's going on. It's simple, but also complicated. It's a skill that can be learned. It's like mixing, it's like baking. It just has to be practiced. Here's the basic anatomy of a stone mill. I'll show you a video in a bit of what ours look like inside. But these kind of stone mills all operate the same way. Grain is fed in through the top through a hopper. There's some type of device that dispenses the grain into the stones. The runner stone there is spinning, and the bed stones below. Here's a few other examples of some other mills. There's an Osti roller, an Astrier, and a Meadows mill. The Meadows mill also uses granite stones, but is situated with the stones vertical, side by side, instead of one on top of the other. Here's a little video of me taking it apart. it's all sped up, but it only takes a few minutes really to disassemble. Let's see. All right, so okay. So the thing to now that you can see what's inside the mill and the basic function of it there, the next thing to talk about is how the millstones work. You can see the drawing here shows the different aspects of the mill. There's the the furrows and the lands, and I'll show you a video in just a second here that explains those a little bit closer. But because this is the mill dress, as it's often called, the old terms of it will also resemble the dress. So the eye was the center part there. The bosom or the breast was the sort of middle part of the stone. Going out a little further, they called the waist, and the very edge of the stone was called the skirt. The skirt is the area where the flour is actually ground down to the final stage.
So the stone mill consists of two stones. There's the bed stone, which is fixed and stationary on the mill, and then there's the runner stone, which spins counterclockwise on top of it. The stone has the face cut in order to grind the wheat. The way we cut that is there are grooves and there are flat parts. The grooves are called the furrows, and the flat part is called the lands. You can see the pattern is basically the same shape if you look at the bedstone and the runner, but we put a few more of these furrows on the bedstone, or excuse me, on the runner stone. The purpose of the furrows is as the grain comes in and comes across the stone, the furrows work against each other like scissors, and this taper here is breaking the grain from the whole grain into smaller and smaller pieces as it travels around the stone. When the grain gets out towards the periphery, it's reduced all the way down to flour and comes out the edge. The purpose of the furrows being having main furrows and secondary furrows, and some of the bigger stones, we have third and fourth rows of furrows, is to act as breaks. So every time it comes around and goes across a set of furrows, it does a single break, and then the second one, it'll do twice as many breaks. If there were more furrows, there would be more and more breaks. Many people think that this back edge is actually what's doing the chopping of the grain, but the reality is it's this tapered edge. This is often called the feather edge of the millstone. I have a model here that illustrates that. So here again, this is the bed stone, and here's the runner stone coming across in this direction. This is a cross section of the furrow. And so the thing that does the breaking of the grain is it drops into the trough, and as it comes around, the grain gets pinched through this edge right here, and it's actually that movement there that does the shearing and the breaking. And that's important because when you're trying to separate the endosperm from the bran, that action of those furrows working against each other is what peeling the bran off of the endosperm, but it's also scraping the bran clean so that you get all of the endosperm removed from there. After it's broken as it goes around, the lands here is the flat, rough surface. That's what actually does the grinding part, and that's what does the reducing it down to a small particle size into flour. To give a sense of what it looks like when these two stones are together and spinning, I have a little model. This one here shows the bed stone, and this would be the runner stone as if it was see-through on top of it. This runner stone here, you can see is spinning counterclockwise, and as those furrows crisscross each other, this illustrates that scissoring or chopping action that happens as the grain gets cut and sheared between each of those furrows.
So when I was figuring all this stuff out about how to cut stones, there are a lot of different ways to cut stones. All of the millers each had their own sort of idea of what was going to work best to get the best efficiency out of their mill. So I looked up many patents. All these millers patented their designs, and they would list the dimensions and the proportions and all the specs and how they cut their stones. But after sifting through a lot of them, all of what they were trying to achieve was to create a higher yield of white flour, faster throughput, and less heat generation. We do a couple of differences in how we cut the stones. If people want to mill and sift, we'll put more furrows in the stone. And the furrows are what do that scraping. And so they tend to leave the bran and a bigger flake, and grind the flour up equally as fine. If the baker is looking for more fine whole grain flour, then we'll leave more of the lands, more of the flat part, and have fewer furrows in there. Because in that case, the lands are doing the grinding, and they'll continue to grind that bran up more and more, so you get nice fine bran with your whole grain flour. That's just another animation of what those furrows are doing as they go around there, and a drawing of what's happening with those furrows as they crisscross and break the grain. There's some mills that use synthetic stones. We use natural granite stones. Osterroller is one of the companies from Austria, that uses synthetic stones. And the idea there is that with granite, it becomes polished over time and gets smoother about once a year or so. You need to resharpen and redress those stones. With synthetic stones, they use a combination of different grits to cast a stone. And as the stone wears, more and more grit's supposed to be exposed so that they become self-sharpening. You don't need to sharpen them every year. But in our experience in talking to other bakers who had used those stones, they found that it works great for a while, but it's like having a chef's knife. You can buy a knife that is supposed to stay sharp all the time, but eventually it's going to dull out on you. Whereas if you get a really good carbon steel chef's knife and you sharpen it and put a good edge on it, it's going to allow you to mill optimal flour more consistently for a longer time. Here I'll show you just how the mill gets put together, and I'll talk a little bit there about how important it is to have the surface of those two stones flat and close together to mill fine flour. So one of the things that's important when you're stone milling is that when the mill is running, the stones are running very close together. They're basically touching, and the grain is what's kind of holding them apart. Because of that, you create a lot of friction, and the stones will eventually heat up. And so what's important is to have a very large stone that doesn't spin too quick. That helps to dissipate the heat that's generated from the friction, but also it gives you ample surface area to do that reduction that I was talking about, where it's cracking the grain and has enough time to travel all the way around the millstone and be completely reduced to flour that comes out the edge here of the stone. You can see if you look down in between the stones, right now they're separated, but you can barely see light through it as they're spinning. This stone actually spins counterclockwise in this direction. And as you lower the stones to the point where they're just touching, skimming until they finally lock up like that. The point where you'd be milling is where they're just barely skimming like this. Because flour has to be reduced down to such a small granulation, it's important to have very tight tolerance between the stones. So operating the mill. These are a bunch of the books that I've collected over the years to learn more about how stone mills work. And the one in the center is interesting. It's called the Book of Wrinkles. And it's a book that we picked up from the Society for the Preservation of Old Mills. SPOOM is the acronym for it. And they've reprinted a lot of these old books, and they're an organization that works to keep old historic water and windmills operating and refurbish them and keep them as sort of museums all around the US. Anyways, what a wrinkle is it's a collection of it's a tip or a trick that millers had that they would want to share with one another. They would say, oh, I figured out how to build this kind of scoop for transferring flour, or I found if I set my millstones a certain way, that was helpful. And so I'm hoping I can share some more of these tips and wrinkles with you in this next part. This is a video of the controls of the mill and how a mill works.
So the operation of a stone mill is very simple because there's really only 3 controls that are involved with running a stone mill. One is you have the speed of the millstone, so turning the millstone on, it comes up to speed. If you'd like to vary the speed, it's possible, but not always necessary. Once it comes up to full speed, the other 2 controls that you have to operate it are the grain feed, so how fast the grain is fed in between the stones, and then how close the stones are together. And by playing with those 2 variables of how fast it goes in and the tightness of the stones, sometimes what we call stone gap or the stone pressure, you can achieve the granulation of flour that you're looking for. Other types of mills, instead of using an auger to feed the grain in, will use a shaker, a chute that vibrates back and forth, and by raising that up and down, you can control how quickly the grain is fed in. In this case, we have a variable speed auger, which is a little screw that will feed the grain in, and by adjusting the RPM, you can control that. In this case too, there's a hand wheel here that by turning it, you can turn it until you feel the stones just start to touch. You don't want to run your mill with the stones empty on full contact for too long because those stones are rough. You don't want them to grind against each other for a long time because it'll smooth them out and they'll get hot and wear sooner than they should.
So then the next phase is how to adjust that mill for optimum flour. But I guess I should summarize a bit of what the purpose of milling is, what you're trying to achieve when you're crushing and grinding that grain. So you're trying to separate from a full kernel, you're trying to separate the bran and the germ and the endosperm. As I said before, with stone milling, everything's getting crushed together. And so the bran is going to flake off initially as it's broken down. The germ gets mashed all into that flour, and then the endosperm gets reduced to a fine powder. The important thing is that you have to break down that endosperm to a fine enough granulation so that you're separating the starches and the proteins. The endosperm has proteins that form gluten, and as well as starch that gives it the content of the flour. If you don't mill it fine enough and those 2 aren't separated, then the gluten cannot form. It's just not broken up, it's bound up. And so you end up with large starch particles, which I call semolina. And because they're too big, they don't absorb water at the same rate as the rest of the flour, and they don't form gluten. So if you have really kind of sandy flour that you've milled, those particles will punch holes in your gluten and tear it up, and they'll absorb and release water at a different rate. And so your dough will just fall apart. You'll have a mess. So it's really important to try to mill it really fine. It is also possible to mill it too fine and have too much starch damage. Typically, when you mill the starch, you need to damage some of the starch, because those smaller broken starch particles is what feeds the fermentation. The enzymes need that to activate and start to ferment the bread. If you have too much free starch or starch damage, the enzymes go crazy, the dough rises too fast. They'll also suck up a whole lot of water and then release it as the fermentation goes on.
We call it false hydration. So it feels like the dough initially can take a whole bunch of water, and then as it ferments, it'll release it and turn it into a big mess, essentially.
To ferment. And it's especially challenging if you have wheat that has a low falling number, meaning that it has a higher presence of those enzymes, because it'll ferment and fall apart much quicker for you. So I'll show you here in this video how to adjust the mill and what I look at as I'm milling it, and then we'll talk about some of the techniques about how to evaluate that flour.
So first we start the mill by turning the motor on. Once it's wound up to full speed, take some of the grain. This is the Bowls wheat from Morningstar Farm. They have the samples of. After the grain is loaded in, then we can start the auger feed. See the grain will start to trickle in. As soon as the grain is trickled in, you can bring the stones together. So as I said, there's two adjustments. There's how fast this is coming in and how tight the stones are. Right now this is feeding in from experience at about 50 pounds per hour. If you go too slow, where the grain is barely trickling in, you'll hear that the stones will start to rub against one another, because the stones are starved for grain. You'll start to smell the stone, and the stones will heat up too quickly. The opposite is you don't want to overwhelm the stones. You can hear it sounds a lot louder, because the grain is running through at such a quick rate that what it ends up doing is taking that top stone and pushing it up and making too big of a gap. You're flooding the stones. So basically, the grain coming in is pushing the flour that's being milled down too quickly, and so you end up with real rough grain, real rough flour. Slow it back down. So the other control is how tight the stones are. If you had the stones pretty open, you'll also get really coarse, sandy flour. If they're too tight, same thing, you'll hear the stones start to rub again. In that case, it'll be the same situation where there's too much pressure, the stones will heat up too fast, and you'll start to smell and the stone in the flour. So we'll back off a little bit. The question then is, where's the right place to determine how these two factors relate? Well, you can only do that by experience and testing. Make an adjustment and collect a sample of flour here. So this looks pretty good. I can smell a little bit of stone smell, but that smell kind of fingers for a little bit, just because when you touch the stones, it takes a little bit for that aroma to dissipate. There's a number of ways to test flour. My initial testing is just my feel. So by rubbing it in between my fingers, you can feel the granularity in there. You can also sort of let the flour out a little bit, and you can sort of, if you smear it, you can sort of see some of the particle distribution in there. Bran flakes in. I'll mill it too coarse right now. Right now this looks pretty nice. With the stones wide open. With this, you can see this is a lot more granular. There's a lot of chunks of unground endosperm in there. Right now I have the stones too tight. Hear them rubbing, but also starting to smell. If you continue to go like this, the stones will start to get very hot. It takes a minute for the flour to switch.
All right, so I talked a little bit about how to evaluate the flour there. The video didn't show in that last sample how excessively fine you can make the flour. It takes a few minutes for the flour that you just milled to sort of move out and then get a clean sample. This is one test that I used to sort of look at the flour, and I actually used the samples of some of the flour that was sent to you guys. What I did here is I just laid the flour out, and I had a clear glass, like piece of plexiglass. And if you flatten it out like that, you can see the different composition of the flour. And it was interesting to see, even in the white flour there from Moulin de Sède, you could really see some of the fine bran in there, which I had never noticed before. And that might account for that kind of creamy yellow color from that flour. In the middle is some of our sifted flour, and on the left is the King Arthur flour. And there's a slight color difference in there. Some of the other ways to test it by touching is to use your fists. So you take a handful of that flour, you squeeze it and open your fingers. If it holds a ball, and you can kind of shake your hand and it falls apart, that's a good indication that your flour is milled fine enough. If it holds a ball for a really long time, that could be an indication that it's ground too finely. If it doesn't form a ball at all, then it means you have a lot of semolina in there. It could also mean that the grain is very dry. I'll talk a little bit about moisture in a bit, but all of this grain is in the 12%, probably 11-12% moisture percent. And so that kind of sifted flour tends to clump together more readily than if you had flour or grain that was really dry. Another way is just to put flour in your palm, rub your finger against it. You can feel some of the granulation there, or rub it between your fingers like I was doing. Some millers I've seen will actually just take a pinch of it and put it in their mouth. Their tongue is so much more sensitive than your fingertips that by rubbing it against the roof of your mouth, you can also sort of sense that granulation. All of these tests too are being done before sifting. This is just taking the whole grain and trying to achieve the nicest, finest whole grain flour that's going to function well for you. The other test I was sort of doing in there is called a slick test, where you can take the grain and put it on a board and use your dough scraper to sort of fan it out, and you can see some of the granulation there. Another test that my friend Jim showed me whenever he's milling a new type of wheat is just to take a measured amount of that whole wheat flour, say 100 grams of flour and 90 grams of water, mix it with your finger in a bowl and let it sit for a minute to hydrate. And then just play with it. Just get used to the feel of what freshly milled flour feels like. If you have a new grain in and you get used to that, you might find that, hey, 90% hydration is way too much, which would indicate that it's a lower protein wheat or something else going on there. So some of the factors that will affect your results when you're milling. So moisture percent. If you get grain in and it's above 14%. Yesterday we talked about, or I guess Randy and Heather talked about grain needing to be below 12% just for stability, for storage. Well, sometimes at the beginning of harvest, or after the first harvest, you'll get grain in that's a little bit higher. And I've had customers who have tried to mill stuff that's at 14, 15%, and it totally gums the mill up. It ends up sticking to the stones, pasting the surface of them, and creating a big mess. That can also happen if your mill is hot, because the mills warm up over time while you're milling them. While you're milling, if you try to mill something that's a higher moisture and the mill is hot, you'll gum it up pretty quickly. The opposite is if your grain is really, really dry. We see this in customers out in Colorado or Montana. They often have wheat that's like 7 or 8% moisture content. And when it's dry like that, the grain is actually more brittle. And so it'll tend to sort of shatter. And you don't always see that separation of bran and endosperm. You'll see that the bran gets kind of milled up more finely, and you end up with a little bit more homogeneous looking flour because it's not actually grinding as well as sort of shattering. Bigger industrial mills compensate for that by tempering the grain, and we've experimented with that a bit, but it's difficult to do at this scale to add water back to the grain before you mill it. Other things that will affect the way the flour mills is the hardness of the grain. Protein is directly related to hardness, so high protein wheats are harder than lower protein wheats. When you're milling something that's a higher protein, like a 15, 16% wheat, often that you'll find in spring wheats, you need to run the stones closer together. It takes more force to mill harder wheat, and you often have to slow down the rate that you feed the grain in order to get nice fine flour. The opposite is true for soft wheat. So if you're milling something that's a lot softer, like that Expedition at 9%, it takes a lot less stone pressure to mill it down to a nice fine granulation. Same goes for the type of grain. If you're milling a soft wheat, but also if you're milling rye or spelt, those are much softer grains, and they don't require the stones to be quite as tight, and you can feed them a little bit faster. One other challenge that bakers often have is if they've milled hard wheat for a few hours and the mill's gotten a little bit warm from running it all day, and then they mill something like rye or spelt that's really soft and can be more moist feeling, they'll end up gumming their stones up that way as well. So I often recommend when they stone mill to organize your production so that you don't run into that problem. The performance with fresh flour. So of course, when you mill it fresh and use it fresh, the aroma and flavor is like nothing you'll ever experience in white flour. Some of the effects that you'll see is that fresh milled flour will ferment a little quicker, and that has to do with having more active enzymes in there. And also sometimes it has to do with more of that damaged starch. Stone milling typically has more damaged starch than roller milled flour. That'll also absorb more water, and that's because the germ and the bran are present in the fresh milled flour. And so people will usually have to hydrate their doughs a little bit more than what they're used to with regular flour. The color will be darker. It can or cannot be more difficult to mix and shape. It sort of depends on how well it's milled, and also the variety that you happen to be working with. So the idea of fresh flour and green flour, we've had a lot of people ask about this. Once that grain is cracked open, the flour will begin to oxidize right away. And that process of oxidizing is aging. It begins to lose aroma and flavor at that point, as soon as it's ground open. But stone ground flour is different because it's whole milled, and the enzymes that give you trouble with fermentation and affect fermentation are in the germ. And so we found that with stone ground flour, the sooner you use it, the more flavor and aroma you find, but we haven't necessarily found in our experience to see a big change in flour performance. In our bakery, we rarely have flour sitting around for more than a week. We mill most of it a day or two before we bake, but that's not to say that stone ground flour that's 2 or 3 weeks old, it isn't going to still smell and taste good. It's still going to be functional. Aging flour that most people talk about is particularly more important with white flour, because white flour has all the germ and the bran removed. It has to undergo an oxidizing process so that the gluten can stabilize in it. So the other test of how to see how well your flour was milled is to sift or not to sift. So I gave you some examples of how to evaluate whole grain flour and try to figure out if you're doing a good job of milling. But it's also just important to, before we get into that, to note the importance of using whole wheat and learning to bake and use whole grain flours. All of the nutrition that wheat has is in whole wheat flour. As soon as you sift it, you start to remove any of that nutrition, and so much of that nutrition is in the fiber and minerals are in that bran. But if you sift, it gives you a lot of different options with what you can do with that flour, creating different kinds of bread, creating different textures and flavors, from a white-ish kind of flour to something that's pretty close to whole wheat. This is a video of our sifter and how it functions. This is called a centrifugal sifter. The first bay there is our sifted flour. These are the middlings. This is the coarse bran here. The way that functions is the whole wheat flour comes in one end. There's a brush that's spinning inside, conveying the flour through the sifter. The finest stuff is pushed through first as flour. The second one is that fine bran, and then the bran comes off the back. Same idea with any other type of sifter. Here's 3 other examples that we've had experience with. The first is a Vibra screener. So that has several screens stacked on top of each other, and the motor on there vibrates at a high frequency, and that shakes the flour through each screen and separates it out. The middle one is an eccentric sifter. This is what we used to use for Meadows mills. That has same idea, several screens stacked on top of each other. It shakes, it sort of oscillates and causes the flour to drop through or pass over the screen to the next level. The last one there is called a reel sifter. This is some of the earliest styles of sifter. This is on an Astrea mill. In that style, that box or that cylinder is tumbling. The flour is dropped in, and as that tumbles, whatever flour is on the bottom and is fine enough drops through into the bottom of the case. So what is it? Extraction. So what we're doing here and with our process, we're doing single pass milling and then sifting it. And some other mills are set up so that you mill it once, keep the fine flour, everything else that's not milled up, you put it through the mill again and remill it until you get all fine flour. That works, but it's also mashing that grain around a whole bunch. And is not necessarily efficient because you have to run your mill several times. So what we choose to do is often called low milling or single pass milling, with the idea that you're trying to separate that flour into the components of flour, middlings, and bran in one pass. We talked a bit about extraction yesterday, and the extraction is the percentage of flour that's sifted off the whole wheat. The thing that's important, though, is that there's not a real system for classifying what extraction is. It's important to know that a flour that is 85% extraction, if it's run through a 275 micron screen, is going to be really different from flour that's sifted through a 405 micron screen. Those are also referred to as mesh size. In our example there, that first screen that we used was a 275 micron or 70 mesh. That's going to yield flour that feels very similar to white flour. That's about the particle size that'll pass through that. The second screen is a 405 micron or 50 mesh, and that is going to sift out the middlings. And we'll talk about those in a second here. Optimally, when we're running the mill, this is what we see through our sifter. We see 80 to 85% flour, 5 to 10% middlings, and 10 to 15% coarse bran, which is pretty similar to what you see coming out of wheat. You know, wheat is 83% endosperm, 2.5% German, 14.5 bran. The variation in your yield is caused by several different things. One can be if your stones are dull or sharp, the duller they get, the more coarse bran you get. That's often an indication of when you need to redress your millstones, is if you're getting lots and lots of coarse bran. That could mean that your stones are pretty smoothed out. The hardness of the grain will also affect those yields, the type of grain, and then the moisture content, as we talked about before. That's why we say that flour is 80 to 85%, middlings 5 to 10. But there is a thing you can do when you're sifting to evaluate your middlings. This is the method we most often use for determining how well and how efficiently we're milling. So we will look at the components, we'll measure them, we'll put in 100 pounds of wheat and then measure how much we get out to get an idea of our percentage. But then we'll look really closely at the middlings to see what they look like. On the top picture there, they're nice and they have a nice tan color. That's indicating that it's mostly fine bran. The bottom one, it's a mix of semolina and fine bran. And so that semolina is what I was talking about before, is the endosperm that's not ground fine enough and is going to end up giving you troubles with your performance with your flour and in your dough later on. If we see something like this, we make adjustments. So we would either slow down the feed rate of how fast we're feeding the grain into the mill, or the stones might just need to be pushed a little bit tighter for that flour that we're grinding. You get several outputs when you are milling, and you have to figure out, how do you deal with them? we call, I guess we don't really have a name for what we call our sifted flour. We just call it our sifted flour. But what we choose to do in the bakery is to mill it at that same way, so we get as much flour, much of the endosperm sifted into fine flour and not into semolina. That way we know we're getting the best yield and also making the most money off of the grain that we've bought, because we're creating the most functional sifted flour. So what we do is run it all that way, and then we recombine it in the bakery depending on what our bread is. So our baguettes, we just use the straight sifted flour. Our country bread, we'll add back in middlings and bran, just kind of depending on what we want that bread to taste like and what the texture we want it to be like. Multi-grain bread, we'll put more or less in, kind of depending on what what we're looking to do. And this kind of goes back to what we were talking about earlier with using the wheat that you get to create different breads, instead of trying to create a bread and making the flour match it. You can do it a little bit in this way. The other challenge with sifting is that when you sift all this out, we don't use nearly the amount of bran that we sift out of the flour. So you got to figure out a way to use it. That's another downside of not using more whole grain flours. We've figured out some of our systems and ways to utilize that. So we will trade that leftover bran with farmers, or with our neighbors who have pigs and chickens, and they'll add it into some of their feed. But a good chunk of it we actually trade back with one of our farmers. He mixes it in with the compost from his cows that he has on his farm, and it ends up kind of going full circle and closing the loop and ending back up at the farm. And there's a picture of the cows who also eat some of the old bread that is left over from the end of the bake.
And that was really one of the biggest challenges, and one of the things that we've really put the most thought into, because we do choose to sift a portion of our flour based on what we can sell in our town of 800 and our demographic of what our, who buys our breads and the style of breads that we want to make. And so because we wanted to be able to utilize all stone ground flour, it was really important for us. And we do use a fairly large amount of whole grain flour, but it was really important for us to be able to figure out how to close that loop and create a system that there isn't any waste. Since we weren't using 100% whole grain, and figuring out how to work with the people who are the folks who are growing our grain, and figuring out how that can fit back into their system is really important, and a really valuable piece of the whole conversation, or creating conversation and relationship with these farmers, and saying, okay, well, you can use this for your compost, and to increase your fertility in your fields, and feed it to your cows and other animals that are rotating in the pastures. And for us, that kind of helps us bolster the whole piece, the whole chain and conversation and level of connection that exists as part of working with local farms and grain growers.
Yep. So that's our PowerPoint presentation. So I think we have a few more minutes. We can answer some questions if there's things that have popped up.
So it looks like Sarah Brannon has a question. Sarah, did you want to ask that? I don't know if you want to unmute yourself.
Yeah, thanks, Heather. Sarah Brannon here from Hudson Valley Farm Hub. We got to visit with you last summer. This is a really excellent presentation. Thank you so much.
Thank you.
On the one picture where you were showing the middlings and the bran, I was wondering, do you ever sift out the middlings and the bran and then regrind it to try and reduce the particle size before integrating it back into the final flour? Or do you just sift it out and then it doesn't make its way back into the final flour?
Right. We usually try to make the adjustment early on when we start our mill every day, so that if we do need to, if we do see the middlings with a lot of semolina in it, we'll make that adjustment. If by chance we made a mistake and have a whole lot of that stuff, it is possible to remill it and get more flour out of that semolina. We just choose not to do it just for efficiency's sake. It just takes much longer to run it 2 times through the mill than to run it 1 time through the mill a little bit slower.
Great. Thank you so much.
Dave Dixon, you had a question too. Can you talk a little bit about how the flour changes between dressings of the stone and how you adjust your mix to compensate?
Yeah, that's a great question. So as I talked about briefly, how the bran flake is an indication sometimes of when your stone mill is getting dull, and that you would need to redress the mill. The other indicators are, we try to keep track of how fast we're feeding the grain into the mill, basically how many pounds per hour we're milling at, and then how tight the stones are. And if those factors have changed from over the course of a year, that might be an indication of having to redress. When you make the stones sharper again, the bran does get ground up finer, and so your flour for a period will be darker. Because in the bakery we adjust the amount of middlings and bran that we add back into our recipes, we will make those changes at the bakery. If you were milling for somebody else, I think the best you can do is to say like, hey, this is the time when we take a break and redress our mill. The flour is going to be a little bit different. It'll change gradually over the first week or so of running that mill. The stones will smooth out a bit more. Your flour will get a little bit whiter, and more of the bran will be able to be sifted out.
Great. Well, we are right near 1 o'clock, so I think most folks were asking about being able to view the presentation again, and I think we got all the other questions. Lots of thank yous in the chat for you and Blair and everyone else. Have a great day and a great season, and we'll see you all very soon.
All right, sounds
Thank
good.
you.
Thanks for having us. Bye-bye.
Bye.